Can you get them to me or somebody, and we can show them?
I mailed them to you and Vladik, and he replied.
Ah.
I did that last night, my time.
Oh, that's odd. Right.
Live streaming on YouTube.
Just got that notice.
We can skip it if you can't find them.
Oh, right. The Voyager ones.
Yeah, I sent 2 slide sets. I sent the Voyager ones, and I sent I thought I sent the Integral ones, the Unicorn ones as well.
Oh, we've got an awful echo. Hold on. Right.
And they're also on a slightly different version of them, but it would still work, or on the HHC pen drive as well.
Okay. Well, what's happening there then? Oh, got it. I've got it. So if I make this work. Hi, what then?
Hello, can anyone hear me?
Yeah.
Oh, so Mark, did you start it? Were you a bit late or what? I was getting very confused messages at my end.
I started it about 2:30.
How weird.
Hmm.
Because it wouldn't let me in, and then it said you've already got a meeting running, do you want to cancel it? And then something. But when I first tried to join, it said the meeting hadn't started, and I thought you were a bit late or something. And then I had to faff around trying to find the bloody password to get in as the host. And the thing, that's really stupid. It was giving me complete nonsense, really. So apologies for whoever I've interrupted. I shall shut up now and maybe just go back as me.
Right. Okay. Well, Chuck, which of the two do you want to go first?
Oh, you found them?
Yep.
The Unicorn one.
Unicorn. Okay. Let me see if I can make this work. Do with another screen showing this stuff.
I do not see the slides, obviously. So you.
No.
we'll do this blind. Let
Yeah.
me know when the cover's up.
Ooh. What happened there? Okay. Right. I think we're
Cover's
good.
up.
It covers up. Can everybody see that? Can we just have a? Is that good? Yeah. Okay. Right.
Okay.
Sorry about the delayed start. Chuck is where are you, Chuck? Corvallis? And has a power failure. So Chuck's on the phone. So I'll you'll have to tell me when to move on to the next slide. Okay. Chuck, over
I
to
will
you.
do that. Okay, so we'll start on the presentation. So first I want to start with a caveat this time. So the Corvallis, Oregon site, at one point, well, just before the merger, HP's merger with Compaq, was the largest site in Hewlett-Packard in the world. And it had, at its peak, it had several different business unit divisions. Okay, the Corvallis division that started out doing calculators divided up, and there was became a components operations, which had the fab, and the personal computing division. And the personal computing division is the calculator division. It still did calculators for a while. Then it did the portables, the Portable Plus. It did the Omnibooks series, the 300, the 425, the 600, the 800. It also started and eventually became a part of it became what was called the Corvallis Workstation operation. Corvallis Workstation operation did the integral, did the unicorn work. It also contributed to some of the HPUX software development in HP. I was not in the Corvallis Workstation operation, so I was not directly involved with either the integral or the unicorn. I was in the first the Corvallis division, and then the Corvallis components operations, which became the Northwest Integrated Circuit division. So I was not directly involved in the projects I'm going to talk to you about. That said, I had friends that were working in the project, and I was a big fanboy of the system and got access to I've got the integrals I have are both prototypes as well as the unicorn. So with that caveat up front, purpose of this presentation is to document the product that would have been the HP 9808, share some of its history, its value proposition, and its application context, share its design specification and its prototype photos, with the intent to preserve its history with this group that might be interested in that. Okay, second page should say HP Technical Workstation Landscape.
Yep, we're on.
Okay, let's start with some context. At the time, HP had, I forgot. The PCD also did the HP85 Corvallis division. Okay, at the time, HP had the transportable HP85, and it had an integrated display, an integrated printer, an integrated tape drive, keyboard. The software was in ROM, so it booted up quick. And the software had applications, and you could have application ROMs and BASIC. And then the elsewhere in HP had the HP 9836 Desktop Workstation. Now, while the 85 was heavy, it was luggable. The 9836 was more or less immovable. It also had an integrated display, had integrated disk drive, keyboard, and software on its hard drive with applications in Unix. Okay, next slide. So where the integral PC fit. The integral was PC was a nice fit in the middle of the two. It was intended as a follow-on to the HP85. It had an improved multi-window display. It had an improved built-in printer, an 8.5 by 11 fan-fold inkjet. It had improved storage, the floppy disk. It still had software and ROM. And at 25 pounds, it was still transportable versus the much heavier 9836. And it was half the price of the desktop. Next slide. Okay, so you should see integral PC use model. This is a picture from some of the sales brochures at the time, and it shows you, it's sort of like a next bench picture of how they envision that the integral would fit in. So you see it's next to instruments, and it's sitting on the desktop and they still have the 85 around. The bottom picture shows it's folded up and easy to transport. They literally have a product picture of it out in a field to show that it's transportable and you can use it in the field. And then there's a picture there of the back of that, and at least in the small version, there's a little square in the back, and we'll talk about that later. That's actually the ROM module for the System 5 Unix. Okay, so the question became, well, what if HP took this integral design and made a low-cost, entry-level HPUX desktop, something below the 9836, less expensive, but very capable for instrument control. Next page. So one of the key source documents for this presentation is the I/L Unicorn hardware design document, and these quotes are taken directly from that document. Unicorn's a low-cost, modular personal computer fully compatible with the integral. It runs the Unix operating system and Unix command applications. Unicorn 9808 is a system processor unit which, combined with a monitor and an HPCalc keyboard, becomes a modular personal computer for technical professionals. This includes support of our Series 80 customer base in the low-cost controller marketplace and as a low-end member of the Series 200 family. This is a very, very leveraged design, and that's why you can see that it was a fast-track project for HP. IDL did happen in February 1985, and its release would have been in September of '85. Now, sometimes fully compatible, we put it in quotes at the time because it should have been somewhat compatible or mostly compatible. But in this case, it was fully compatible. Next slide. IPC Unicorn Software Design Center. Is that up?
Yep. Mm-hmm.
Okay. So first, and for the people that were at HHC, I'm not sure if you caught on to it, but in this presentation, the titles of the slides, a lot of them are coded for either integral with the electroluminescent dot font or in the black on gray unicorn font from what it would look like on its display. So the Unicorn Software Design Center and the IPC were exactly the same. So it was the ROM-based environment. It used the exact same hardware ROMs for HPUX-RO. It had the friendly user interface, the multiple windows, menu soft keys, supported the ITF mouse. The getting started tutor was the same, foreign language, localized. All of the optional features HP Technical Basic, the peripheral support, the applications, and the language. All of the software is exactly the same. So fully compatible means exactly the same software. Okay. Next slide. From a hardware perspective, again, it was very heavily leveraged. And the Unicorn system design started out as an integral design. It added 2 I/O slots, and it changed the video from driving the electroluminescent panel to a 640 by 400 black and white video output. It also added options for additional internal RAM, a second floppy, and an internal hard drive. Okay, next slide. So the Unicorn system block diagram looks a lot like the integrals with the noted exceptions. And on the chart, you can see the things that are different starred in blue. The Nighthawk hard drive and disk controller at the left of the diagram, top right, the 4 I/O slots. At the bottom, the 128K of display RAM. Okay. Note that the Unicorn used the same graphics processing unit that Dean Heath designed for the integral. It worked just fine driving the video display. So with this background now, let's look at the prototype system. Next page. So opening the Unicorn. Top left, you see what they call the system processing unit. It looks a lot like a modern day PC with 2 floppy drives up front. In the top right, you can see I'm sliding off the top cover. In the middle, you see a little U-shaped thing that shows you what the top case is shaped like. So there was bins on the bottom such that you couldn't lift the top off, you had to slide it off. So I slide the cover off and you see the picture of the opened unit. The picture on the left is got the back towards the bottom, and you can see on the left side is the power supply box, the right side is the card cage for the I/O. You flip it around so the front's towards us, you can see the floppy disk, and you can see there's a sheet metal covering the insides of the box. Okay. Next page. So if we fold up that sheet metal panel, you can start to see the insides of the Unicorn. There's 2 major printed circuit boards. Along the bottom of the whole case is the main logic board. It goes under the hard drive on the left and the floppy on the right. The disk controller board, which is an optional part, it's actually for the B product, is secured to the fold-up panel. Then there's a little PC in the I/O card cage that you can't see, and they also say that there's a printed circuit in the ROM assembly, and we'll show a picture of that in a minute. Next page. Okay, so if I were actually logged on here, this is a bigger picture. I point out the fan, which is that thing in the middle you should be able to recognize, the floppy, the main PC board, the hard disk controller, the Nighthawk hard drive, which is secured to vertically to the left side of the unit. And that PC board, the main PC board is just one big PC board that actually extends under both the floppy in the front and the I/O card cage in the back, and that's what I try to show in the picture on the right. Next page. You got it up? Unicorn product specifications, CPU on the right.
Yep.
Okay. So right under the fan is that I'd normally point to is the 68,000. You can see the system logic towards the middle of the picture, and in the top right, you can see the socketed RAM. Okay. Wanted to get a bigger picture so that people can see it. Next page. Okay. The top picture on the left shows you the Rom port. And for those that have an integral, and remember the picture I showed of the back of the unit, that plastic is exactly the same tooling that's used on the integral. So when they say compatible, they mean you can actually take an integral ROM module and plug it into the PC board on the Unicorn. Okay. You can, and then there's a picture in the bottom right, a bigger picture of the socketed RAM, and we'll talk about why they didn't populate out the RAM a little bit later. Next page. So for reference, these are the Unicorn memory maps with the IPC differences highlighted, and you can see in the middle at the bottom the extra RAM that's used in the extra internal RAM for the Unicorns called out. On the integral, that's just said that it was it's reserved. And then on the right hand side, there's at the bottom of the memory map, you see that there's ROM called out, and I believe that's the ROM that's actually used for the disk control. At the top part that's highlighted that's different, it's actually, I believe, the same as the integral. It's just that they specify out in the Unicorn hardware documentation what the different address spaces are used for, and in the integral service manual, it only calls out that these are ROM. Next page. Okay. This is an enlarged picture of the disk controller board. Remember, this was mounted to that fold-up front panel. It connects with flexes to the main PC board and the Nighthawk drive. I mentioned in my HAC presentation that my Nighthawk drive is non-functional in the prototype unit I have. I've since been talking with someone that has two partially working Nighthawk drives, and he's also suggested some things I can try to get mine working. So haven't had a chance to work on that yet, but we may get that up and running. Even though the Nighthawk is non-functional, the integral works just fine. It basically works like the Unicorn's just fine. It works just like an integral. Okay. Next page. Okay, so filling out some more of the Unicorn product details. You can see a picture of the back with 4 card slots. You can see the HPIB and the HPHIL. And for those that aren't familiar with the HPHIL, it was HP step from HPIL to the world we live in today, where we have USB peripherals. So it was a loop that was more of a daisy chain. You didn't have to make it all the way back. So in the integral, the mouse and the keyboard both plug into the integral's 2 HPHIL slots in the front. The Unicorn is more HP standard HPHIL in that the mouse plugs into the keyboard, and in the bottom right hand you can see that there's 2 HPHIL plugs on the Unicorn keyboard. one plugs into the display, and the other is for the mouse to plug in. And the HPHIL, for those that are familiar with it, had a standard 1.2 cables. So, next page. So, Unicorn product spec should have the display up on the screen.
Yep.
Okay. The display has two HPHIL connectors in the back. You can see that in the picture on the right. In from the Unicorn system and out to the keyboard. Okay. And you can see the video and sound inputs from the system. So why does a monitor have an HPHIL connection? Well, that's for a touchscreen, which is that gray enclosure on the front of the monitor. So the Unicorn was a touchscreen windowed computer. Okay, next page. So sort of like the old HP profit sharing announcements, when they did the profit sharing announcements, when the actual number was like one of the last things they said, so they tried to keep you in suspense. So here's finally, way into the presentation, the first picture of a Unicorn system. Okay, this is an assembled working Unicorn system. It looks like this. It's a stack of an HPIB ThinkJet printer on the top, of a touchscreen monitor on top of a system enclosure with an HPHIL keyboard in front and HPHIL mouse out front. The stack, I've also stacked this with a 9133 or 9134 under the monitor and on top of the system, and adding a hard disk to the system, of course, expands its capability a lot over having to flip floppies. Next page. Okay, here's some screenshots. You don't see the lines, of course, with your eyes. Your eye integrates it. Even without the Nighthawk hard drive, the system boots up and runs like an integral with the extra RAM, and that's noted in one of the windows there. And the touch screen is a nice addition to the mouse control. So it just is a helper on the mouse. And you can see on the right-hand side that some of the utilities that the Unix utilities that are in the software engineering ROM module. Next page. So this is all a part of my little archive project. I've scanned in my copy of the Unicorn hardware design document, which was a key reference for the presentation, as well as all of the integral PC documentation I have in both 300 dots per inch, fully searchable PDFs, and 600 dots per inch TIFF, 1 page per TIFF scans with no processing per Eric's recommendation for documents. So you can see the list of documents there. I think most of those have already been available. There's some that are new. Okay. Next page. Reflections on the integral PC and Unicorn. So as an afterword or summary, I found this note out on the web. Alan Barrow was responding to a post that the IPC was a failed product because it was overpriced. And he appropriately took exception to that, and he said, interesting comment on the expense. The IPC was priced comparable to the Mac, had double the memory, and a printer to boot. It wrapped a user-friendly windowing system around Unix in a portable fashion that did not require program recompiles, etc. It had a faster CPU and expandable memory. The list of advantages goes on. The Fat Mac, which matched the memory, was much more money. HP simply did not market the IPC well. There was internal competition with the Bobcat series workstations, Series 300. In fact, the IPC has dual serial ports in the hardware, but the driver was rewritten for only one to work on the IPC, as the IPC could not have a MUX to avoid competition with the 9000s. Also, the IPC motherboard was only half populated with memory, as are many of the add-on memory cards due to internal competition issues. The killer IPC that was killed before final release was the mythical Unicorn, which had a built-in hard drive and more memory. It was to have sold for $49.95, if I remember correctly, and he did. At one point, I knew of a couple people that had them, and there's a few out, and you see one here. The addition of the Stone Tools ROM, which effectively adds mainstream Unix command set to the existing kernel and basic commands, made the box a powerful package. The base OS was Unix kernel, basic Unix command, and a windowing system called PAM. It had a file manager, text editor, and would happily display character mode Unix programs as each window emulated a terminal, much like the X Windows developed much later, by the way, by some of the same folks. No networking was allowed, alas, although there was a way to work around that. The IPC would work with any of the HPCS80 drives and tapes, and the 9133H was a common accessory. The two I/O slots could be expanded to 6 with a chassis expander, which was required for the 5.5 megabyte fully loaded RAM. Mice, graphics tabs, and larger keyboards could be connected with the HPHIL. Full Unix command set was available via floppy and could be loaded on the hard drive in typical HPUX locations. Fix your path variable and you had a nice Unix system for its day. Remember that the kernel was in ROM, so no boot, so the boot was quick, and so was much of the command access. It could create RAM disk as needed as well, so you were not dependent on the floppies. Main intent and success of the IPC was as an instrument controller. It made a nice package and was a good replacement for the HP85. Business applications were never targeted. And so the Unicorn was the next logical step. It was a desktop version. Its main problem was that it was too darn good, and it was significantly less priced than the workstations, and had similar capabilities. So it didn't go out because it would have been too much of a competition for other HP products. So please let me know if there's any additional information that would be good for me to add to this collection for posterity. On a side note, I'm just beginning to sort through the HP IPC floppies I have. I've got all of the floppies from the Employee Computer Center for the IPC. And as I put in a plug, if anyone's interested in helping repair the integrals or Nighthawks or 9133, 9134s, please let me know. That's it.
Thanks, Chuck. That was great. Okay, has anybody got any questions?
I do.
Please go ahead.
Chuck, what is IL, I/L?
Interface loop.
Well, the spec, not HPIL. You had the spec at the beginning. The spec was released IL, I/L.
Oh, that IL. Okay. Yeah. That's HP product lifecycle lingo. That's investigation to lab. So there's HP followed a pretty rigorous product life cycle. I've been in 4 companies since, and I've actually leveraged the life cycle from company to company. And it was a phase review life cycle. So there were different phases of the life cycle. The first was an I phase, where it's investigation. So that said that the lab could go off and do an initial investigation, and the amount of investment was limited. Then there was an investigation to lab. Now, at that point, that was the kickoff for the project. That was the point at which the division was authorized by division management to go off and spend a fair amount of money. Again, determined at the budget was set at the IDL meeting. And so this is typically, the IDL is when the project kicked off and became a real project in the lab. Then there's LP for lab proto, PP for production proto. If there's a chip release involved, an integrated circuit release, there was it ran on its own life cycle, and it had a key checkpoint for it was the artwork release, where you went out and spent tens of thousands of dollars on masking and that kind of stuff.
I also have some specs for 71 documents that it references ICC release. Is that a similar phase or something?
I'd have to go look at. I don't have the context for what that is. It doesn't. It's not a familiar. It's one of the many checkpoints, but I don't know what it is.
Okay.
Now, by the way, when you said IL, the HPHIL is the HP Human Interface Loop, which is the follow-on to the HPIL.
I didn't realize that. So HIL was derived from HPIL?
Yeah, it was the next generation.
I didn't realize that.
Yeah, it was HP's basically attempt to take us to take peripherals, PC peripherals, into what we have today in USB land, where it's plug and play, and the peripherals would work across the product line. So all the peripherals that would plug into an Integral or a Unicorn would plug into the 9000 series, all the way up to the big iron.
I recall
Very
one of the things from HHC I said I would send you, but I couldn't remember what it was. But today it reminded me the information about the utility that lets you create images, both create and use images to create media that runs on current day Windows. I'll send you that information and a list of the diskettes that I have to combine, to make a larger set of what you have, so we can have one combined list of all the media that's available.
That would be good. Yeah, I think the first step for me is to work with you to get a catalog of what's out there and available. There's also in the groups.io, there's a person that's building a hard drive image, a LIF image for the Integral that's supposed to have all of the software in it, so that if you have a 9133 or an emulator, that you could put that on there and have a hard drive, a fully loaded development system for an Integral. And I have been digging into, since we've talked, the various HP disk emulators. There's one, as I think most of the folks on the call know about, the HP disk software emulator, which is, requires an old PC, an HPIB card and whatnot. There's an HP85 disk, and there is another HP disk that Ander is doing, which right now it does emulate a 9133, 9134 with an SD card, but he's got a person that he's working with to test it out, and the Integral is sending out some non-standard, as far as he knows, CS80 codes. So it's not, that system's not working yet. That emulator's not working yet for hard drives. But I'm pretty interested in getting at some point a one of these little HP disk emulators, so that you can plug that into the Integral and run off like it's got a hard drive.
That would be cool. I'll put me down for one of those as well. Daniel Doherty on YouTube asks a question. In 1985, where could one have bought the Unicorn at retail, assuming it had ever been launched? Comp USA, Sears, or was it purely a channel?
It's a channel. HP, you bought directly from HP and HP's distributors.
Yeah. Okay, thank you. I'll try and see if I can see any other questions anywhere.
One other thing, a guy, I'm trying to think of his name, Mark Beelman, who also was at Corvallis and maybe on the product team, has made basic ROM plug-in boards. There's sort of a dot board that plugs into the back of the main ROM module that gives you basic in ROM, very much like the basic from Series 80.
Oh, excellent. Well, that was a standard HP product. So he's got a daughter board that he's selling now?
Yeah, he made several of them. I have one.
Okay.
He's
Thanks.
also he also has threatened to make a modern version of the software engineering ROM, but that's obviously a much larger. I think it's 16 ROM sockets, and so it's a much more involved build than just, I think, the 4. If I'm not mistaken, it's just 4 chips for the basic plug-in one. That one would have to go in the interface slot.
Yes. Now, Bob, I have been looking at given some of the extra information that's in the Integral Service Manual and the Unicorn hardware description. We could build. I mean, the technology makes the Integral system, look the new technology makes it look very simple. With 1 flash chip and 2 RAM chips and decode logics, you could have a fully populated on a card. You could have a fully populated Integral system.
Wow.
So yeah, I mean, literally, you need 2 RAM chips because of the way the 68000 does addressing, but that would give you a fully loaded Integral system, including, and you put the software engineering ROM on flash.
Wow, so you'd have all the software at the speed of ROM? That'd be great.
Yeah, and that's what you basically get. And yeah, so if Mark is thinking about doing that, I should reach out and check in, because I'm more of a software guy than a hardware guy. But if someone's used to building programmable logic, it's not that hard. I've got the logic diagram for the address decode already figured out.
I'll mention it to him. I think he's still in Corvallis too, so it's probably a local. You could hook up or whatever.
Yep. Thanks.
Thank you. No, this is cool.
Thanks, Chuck. I can't see any more questions on YouTube or on the chat. Chuck, do you want to do?
On the other presentation, I request that we not do that because
Okay.
I don't have a copy of that in front of me. I was not planning. It is still, actually it's starting to get light outside, but I don't have I had my speaker notes and presentation for the Unicorn, but I don't have the presentation hard copy for the 17C. Perhaps another time. It's a shorter, fun ditty type thing anyway.
Yeah. Okay. Okay. Or maybe if your power comes back on, maybe we could do it at the end, just for a bit of fun. But and you might be able to see it then. Okay. Thank you very much. Shall we move over to Sylvan then?
Yes.
Okay. If he's there, there he is. Have you got the sharing option, Sylvan?
And we just got electricity.
We don't have that for you. I've got your slides, Sylvan, but not sound.
Anyone hear me? I don't think anybody's not hearing anybody.
Not got sound still from you, Sylvan. Gremlins Day, clearly. Chuck's got no power, Sylvan's got no sound.
Actually, power just came on. I'm booting up my computers and logging in.
Oh, okay. We might be back to you then from it.
You have sound now?
Yes.
Yes.
Perfect. Okay.
Super.
Sorry.
That's all right.
I tried to do I'm doing sharing in WebEx, but it doesn't seem to share. Like right now, sharing is activated.
Yeah, we can see it. We can see it.
Now.
Okay,
Yeah.
good. So
and sound are good.
perfect. I don't know what you're seeing exactly.
Yeah, we've got the presentation's good. Yeah.
Perfect. So This presentation will be a 7-slide presentation and a live demo. This is about the FRAM71 and the FRAM71B modules
Record.
Has left the meeting.
that has been made by Hans Brueggemann. That module is basically RAM that you add to an HP71B handheld computer that expand the RAM on the machine. And you can configure it differently. So you can replace the OS or add RAM to a specific place that sometimes is needed for the ROM modules, the Fort modules, sorry. There's for each module, the FRAM71 was the first generation modules, and the 71B was the second generation. The first FRAM71 was only available mostly in 512K. There are a couple of 1 megabyte that has been made. On the FRAM71B, you could buy it in the 512K or 1 megabyte, but in both cases, the 1 megabyte was made mostly a 512K with a daughter board, a memory add-on daughter board of 512K. So that's it. The configuration string is the same for both, but has different meaning depending on the module. So that's the FRAM71 module. This is a configuration spreadsheet that allow you to create a configuration string to configure the module. But there's a lot of gotcha in when you do the configuration, and it's very easy to not do the configuration correctly. So the spreadsheet try to prevent you to do that. There are two versions of the spreadsheet, one for Apple numbers and one for Microsoft Excel. I'm on a Mac, so I develop on both, but I haven't tried it on Excel for Windows, but I'm assuming that it's going to work. There's no macro. It's only standard functions that has been used, so that should work. I've bought Excel 2021 for Mac and try it on it, but Microsoft Excel all the product of 2021 crashes when you try to start it. They're not working right now, and they release an update and it's still not working. So I had to uninstall it and reinstall 2016. The presentation and the configuration spreadsheet is available on the Museum of HP Calculator at that space. So also there's a bug in Excel 2016 that if you try to do conditional color formatting, for one color it's working, but as soon as you add the second one, everything crash. I tried on try to make it works, but it's not. So the Excel, you will see that when you have error, you can have on the Apple number, you have the color coding. You don't have that on Excel. So that's what looked like the spreadsheet. The spreadsheet has 16 rows representing one chip. In the 71B, you have a module. A module is built on chip. And this is how you configure the FRAM module also. So you create chip, and a set of chip will create a module. So and at the bottom, you see the configuration string, the poke 2C00 and the following. That's actually the command that you have to enter on the 71B when you have a valid configuration. So this is now how you configure that, how you use the spreadsheet. The first thing is that you select the module. You can select 71 or 71B. Then for each row, you will activate or not the row. that will add the virtual chip to the configuration string. Then you select if this is the last chip in the module or not. So when you have only one, you create a module for a chip, you have only one, you will select that. But if you have several chips in a module, you will select that option only on the last one. Then you have to select what type of chip. Is it chip? Is it RAM, ROM, hard configured RAM, hard configured ROM? Chip size. You can select 32K, 16K. On the FRAM71, you have 8K option. On the FRAM71B, you don't have that anymore. You have, if you have the 1 megabyte version, you can select between the standard 32K or the top, who is actually the bottom 32K, and the top 32K. So that's the T32K. Then you have to select the memory block in the FRAM. It's 0 to 15. 0 and 1 has special meaning. 2 is reserved for configuration. So actually you have 3 to 15 available for most of the configuration. And then you can enter the chip usage. This is basically a comment. So as you enter that, you will have a section which is called input validator, and that will validate the row and also the spreadsheet, the module in itself with the multiple row configuration. You have also the configuration builder. That space will try to build the number that will be added to the configuration at the poke at the bottom. So that's basically how to do this. Now, if you look at an example of a good configuration, you have here all the rows that as a configuration has been enabled. Those are mostly two chip modules configuration. You have a set of RAM, ROM, you have chip size, the memory block that's been used, and the validator is mainly magic numbers that is being used inside to validate the input. And then at the right, you see the builder was basically creating, assigning chip numbers, addresses, and configuration value, and the port that will result when you're going to use on the 71. And at the bottom, you have the full configuration string that you're going to enter. Next, if you have a non-valid configuration, you will see color-coded errors. And you will see that validators will generate errors, builder will not be able to build correctly, and the configuration string will not appear. So the configuration string only appear when everything is working and has valid values inside. On the spreadsheet, you have the first page you will see it's an information page. That page contains the description of all the columns and the title and what it does and all the options for the input, the validators, the builders, and the configuration at the bottom. Also, you see on the right side the error that you will see in the spreadsheet if you make an invalid configuration, the name and the description of what it is. And also you have rules. There's rules for 71B. You cannot, a module must be completed with else the last chip in modules. Mixing, you can only have the same type. You cannot mix a mod. You cannot have a module with a mixing RAM and ROM. All the chip must be on the same size. So if you select to have 8K or 16K chip, all the chip in a module might have 16K. On the FRAM71B with 1 megabyte 1 megabyte option, you can mix the 32K and the bottom 32K and the top 32K. Because it's 32K, it's okay. Memory block 2 is reserved, cannot be used because it's reserved for configuration. Hard configuration address for the translator ROM and the Fort ROM can only be used on chip 0. And system RAM for FRAM blocks 0 and 1 is actually supported. I haven't forgot to remove that. So that's it. We're gonna go to, I'm gonna trying to unshare that and sharing a spreadsheet. How can I do stop sharing?
While he's looking for that, I'll add one thing of explanation for people who are not 71 users. The way this works is it's connected on the card reader I/O ports, and you just poke an ASCII string into that port, and that is how Hans uses basic I/O to configure it. So what this thing is doing is building up the string that you poke in there that you otherwise manually figure out by going through this whole process by hand. So this is going to dramatically ease the ability for people that want to configure this and don't want to fight through it each time. I can tell you from experience that after you don't do this for several months, you kind of have to learn it all over again.
Yes, and also you got the difference between 71, the France 71 standard and the first generation of France 71 and the France 71B was a little bit different. Okay, do you see the spreadsheet?
Yep, it's a little bit small. If you can make it bigger.
Okay. Is it okay? Is it bigger?
Yeah, much better.
Okay, I can put it really bigger. Oops, no, that will not work.
Oh, that's good. The full screen one there that you had.
Wow, I was worried because I have a 4K screen. So, okay, that's the page that was the first page that show you the options. You got a template, and I've put a worksheet. Normally, what I do is I duplicate the template. So, and I move that to the end, and I will say config 01. Okay, so what happened? If I click enable here, at first I select which module I want to. So it's either FRAM or FRAM71B. You can change that at any time, but the whole spreadsheet will only validate against one module at a time. So let's say a FRAM71B module, if I enable it, you will see that right away you got a lot of errors. You got, because I have not selected the others, you will say that the last chip in the module is missing. You got missing value here and error. It's not able to build correctly. So as I populate the thing, you will see that the error are removed. So I'm gonna create one chip, one module chip. So I'm gonna select RAM here and 32K, and I'm gonna assign the block 3. I could put any comment here. And when I do that, sorry? Sorry?
Make it larger. This screen is small.
Okay, sorry. Yeah, you're right. Is this good?
Better.
Okay. So right now I've created a module as everything is okay. Chip 0 has been assigned the first two address, is able to create the good configuration. It's port 5 in the 71B. If you free that port, it will have that address. And the string at the bottom is the configuration you must enter in order to have, when you do that, you're adding actually 32K of RAM to the 71B. If I create another one, again with one module, when one chip in a module, let's say I'm doing the same as before, and I'm assigning a different one. When right now I'm adding a second 32K to the 71B. If you free that, you're gonna see that it's gonna be at port 5.01, and the configuration string at the bottom is 939400. Now I could, instead of having two different modules, I could have one memory modules of composed of two chip of 32K. And if I do that, I will remove that option here, the last chip in module, and I just create a module with two chip of 32K. And the chip are there, and then you will see that now the two chips, you have only one port of 64K. If I do the same again for the same thing, 32K, I'm giving, all the time I'm giving a different memory block. And if I remove the last chip, now I have a 96K modules built with three chip of 32K. Now, if I try to do things like same memory block, it will say that you cannot have two chip with the same memory block. That will not work, and you will have an error. Same thing here. If you select any RAM here, it will say that there's an error. But that may not be an error here. If I create three modules, that's no problem because each modules have only one chip, and there's not error. But if you try to select multiple chip type in the same module, that will not work. Those are kind of error you could do, and when you do this manually, and you can spend some time trying to figure it out. Okay, also if I try to use, try to use a memory block 2, it will give you an error because that's a reserve value. You cannot, it's used for configuration. If you try to use memory block 0 or 1, it will say that it's a good one, but it's a system memory. And you have a warning at the bottom saying that it's a system FRAM. You have to add a jumper, and also you have a LED that's going to be light up, and that will drain the battery. So normally you don't use that. You use 0 and 1 if you want to replace the OS. Like if you have a 1BBB machine and you want to have a 2C machine, you can replace the OS, load into the FRAM a new version of the OS, and then activate that. And when you do that, you place that into the system RAM, and with a special module jumpers, you replace that. Also, hard configuration. If you want to select, let's say I'm selecting the 3. Also, all the enabled, you can disable a module at any time. And if you disable that, all the configuration will adjust. So it will use the first row, not the second one, the third row, and the address here are dynamically reassigned, and everything is dynamic. If I take the first one and say I want to use it as a hard configuration, I'm going to go here, select the last chip in the module, and say I can use the hard configuration RAM. When you do that, that means that you want to populate that with the fourth RAM, the hard configuration space. The port will disappear because that will not be showed. It's in part of the configuration, but it will not be shown. If you try to do this on a second, let's say I'm using this, it will say that you cannot define a second hard configuration RAM or even define one with chip different than 0. It must be the first chip. If I disable the first row, the hard configuration RAM become the first chip in the chain. That will work. But if you try to define the second one, that's all kinds of little bit here and there that you have to be aware when you create a configuration that can bite you. So that's it. You got on the website, on the HP forum, the configuration is there, the templates, the presentation is there. You got a small transaction also. and I have, hold on. You will also, I don't know if you can see the new one. Close this one. Okay. You also on the forum, you will see another version with development version when you have, okay, I have to do this to 100% on each one. All the test cases that have been used that can also show you what's working, what's not working is part of that version of the spreadsheet. So you have here the spreadsheet test suite 1 with a single chip module configuration with good values. Same thing for the test single chip again, the second test suite. But the third one, it's invalid chip, invalid configuration one for one chip module, and for each what I was trying to test on each one. Same thing here. So basically you got a single chip, then you're going to multiple chip with good configuration and invalid configuration also. So that's it. Any questions?
Thanks, Sylvain. Eddie's asked on the chat, 1 hard RAM per configuration. I'm not sure if that was a question or a comment.
Yes, because you can now, hard RAM is mapped to the E address. So it's you can only have one, but you can yeah. So you're loading like the Fort RAM or the translator RAM. You're gonna load the hard configuration part to that RAM, and then with a special you're gonna reallocate that to the E address.
Okay.
So you can only have one per configuration.
Thank you. So the rest of the ROMs are like you can just do your own user programs and store, and they're available for user programs and files.
But basically with the RAM, you're adding RAM to the 71B. So yeah, my video was stopped. Okay.
Thank you.
Basically, you can add to that RAM, or when you add RAM, you can put it on the system RAM, okay, or you can put that as a individual independent RAM. On the ROM side, is basically the same as RAM. It's just this flag that's checked that is saying that it's a ROM. So normally, it's what you do is that you define an IRAM, you load the module in it, and then you change the configuration to a ROM.
Sylvain, to do that, can you simply configure them as RAM and then go load them all up and then get to write string to change it? You just go through and go down the column and toggle RAM to ROM to generate the new string?
Yeah, what I will do is copy the template for the first configuration and then do my first, if I have multiple step configuration that I need to rechange the same configuration on and on, I will first take the template and say config 1, let's make a copy of it. And then when the first one is done, I will copy the first configuration and rename it as a second step.
Yeah,
And then
okay.
change my thing, copy the second step to the third step, change the thing. So I will have a spreadsheet with, let's say, 6 or 7 steps inside, and each step will reflect the configuration at a specific time when I'm trying to load like when I'm trying to load the OS and different things.
So when you want to define them as RAM, load them up with stuff, and then reconfigure them ROM, all I have to do is go down the column and change RAM to ROM on the affected ports, and I have the new string.
But if I want to get to keep the history of my configuration,
Sure, you save the file. Yeah.
I will not copy the file, just copy the slide, the tab.
Yeah, yeah,
The
yeah.
so I have all the full configuration like in 8 or 9 tabs inside the same spreadsheet.
Right, for each machine, yeah. That's
Yeah,
what I do. I keep a personality one for each machine.
yeah, that's it.
Really impressive. As I've told you before, of course, real men figure this out the hard way and don't use spreadsheets, but really, really impressive. This has got to be one of the most complicated spreadsheets you've worked on for sure.
Yeah, the problem is that I could not use macros
Yeah,
because Excel on Mac has different macro language than Excel on Windows. Also, numbers is different. So I was trying to do this only on with formula, and the problem is that that has to validate against rows.
right,
So you
right.
have to validate on both rows and columns, and that was not easy. Took me 6 months to figure it out correctly.
Really impressive.
Possibly a question on many people's minds if they've not got a FRAM. Do we know if Hans is going to do another batch, or is that it?
My understanding is Hans will not do another batch. Okay, he has make I think 3 batches or 4, but basically the first generation was 2015 with the FRAM 71, and then in 2016 he released. He made another batch for the FRAM 71B. He made another batch in what 2020, 19.
Yeah,
He
20.
he made 3 batches and said that was the end, but then
Yeah.
there was enough demand that he made the 4th batch. But he said that's the end, really. I mean it this time.
The problem is that components are becoming hard to find.
Yeah.
And I think that what he says is that he has gone on to other projects. So basically, what we have as FRAM that on the market right now, that's what's going to be. So you will have to buy from another user.
So this is an appreciating asset then.
Exactly right.
Yes, I have several of them.
I thought you might.
Oh yeah,
Um,
too.
Shocking.
Dan, sorry. No. Multi-mod is an alternative to FRAM,
Yes.
but only for ROM. Is that right?
Yes. Dan is there, so we can.
Mark made
No.
that. That
Oh
was
yeah. Sorry, my fault.
yeah.
Yes, it's not as powerful as FRAM, but it's like if you compare the Clonix module with the NOV module from Diego Diaz. It's
Exactly.
basically the multi-mod module is for it's a flash-based module. You load the module inside, and then you activate the module. With the configurations, only 1 byte. So you can deactivate the module, activate the configuration that's there, and you got a second mod, the second option also to activate an extra 16K or 8K, I think. I don't remember if it's 8K or 16K. The U extra ROM, but that's basically it. So
It's just for ROMs, and also
yeah,
it does not cover the case of the 4th, does it? Wait.
I think yes, but not the OS.
Yeah, exactly. You can do the 4th and the translator, but not the OS.
Yeah.
So it's a much simpler. There's no RAM per se. It's only ROM.
Yeah.
So you
Okay.
cannot do something like right now. I'm gonna show you something. Trying to put that so you can see it.
Ooh. No, you're back. It's
I will
background.
deactivate this again. I don't know how.
Under the stop video, change virtual background.
Yeah. Done. To stop and start the video again. Work.
No.
Okay, I'm selecting none, but it doesn't seem to work. Right.
Does anybody know if the multi-mod is still available?
Yes.
It is, yeah.
I think it is, yeah.
So HP 71 fans who don't have one of these, multi-mod is your option at the moment.
Yes, right now, yes.
Yeah.
But with the FRAM, what you can do, I don't know if you're seeing it correctly.
Yeah.
Get the version of my ROM of the 71B right now. So, and this is the machine. Now, if I want, I'm using a special module. It's called OD that you have to define that only works in port 1. That when you plug that and with a good configuration, you select another version of the OS. So if I remove that module, and if I show the version, you will see that that machine is really a 1BBB machine.
Yeah.
Okay, so this is done with the FRAM 71B module. On the same machine right now, I have the 1BBB, the 2C DCC, and the 3EEEE. So depending on what I want to test, I can select which OS I want to run on. And this can only be done with the FRAM module. But right now, you're right. The multi-mod module is the only one that is still available that you can buy. It's great. It's working great.
Yeah.
But it's a
It's
different
also
module.
far cheaper than FRAM. The
Yes.
multi-mod was very, very inexpensive. So anyone with a 71 that just wants to be able, I mean, you can buy the multi-mod for less than you would pay for one module, for one ROM module on eBay. So for most of them, so you can have pretty much anything you want there.
It's a lot cheaper than buying the module from eBay.
Yeah.
Of course, that's easy.
Yeah, but so right now the only option is to buy it from a current user.
Okay. Thank you,
Question?
Sylvan.
No, perfect.
Any other questions? Ludwig.
Yes. Does the raise hand icon not work?
I can see it, but it's tiny.
It's tiny. Yeah, sorry.
Right. So I should shout or wave my hand or something.
Go on. Yes, Ludwig, please.
Okay, my first question was going to be, what's the chance of finding a FRAM on eBay? Are they popping up? No. So the next question is, could you provide us with a link to the multi-mod? I guess I can just look at it up on Google, probably, can't I?
Well, you can go in the forum, but I will give you give me two seconds, and I will give you the link to it.
Okay, thanks very much, Sylvain. Thanks for the talk.
Come.
I think Bob's point about you configure these things. I configured my perfect FRAM 71B configuration, and if you ask me to go and redo that configuration now, I've got no idea how I would do it, because it was such a. I've got a log file which is pages and pages and pages of how to configure it, and so I'm planning on never touching the contents of that module if I can avoid it.
By
That's
analogy, I find it very similar to configuring the CL.
Yeah.
After hours of reading the book and writing down notes, it's easy, but to just pick it up months later or a year later is just start all over again, for sure.
Absolutely. Okay.
I just put in the chat the link to the thread that I create on the forum for everything about FRAM. Now I'm gonna put also the other one for multi-mod.
Just while Sylvan's doing that, thank you, Sylvan. That was great. Chuck, are you with us again?
Yes.
Do you want to do the other one? It looks fun. If you're prepared.
Sure.
Yeah. Do you want to try presenting?
Yep.
Please.
to,
This is the world premiere of this one, is it?
yeah. As such, let's see, how do I share my present there? Share web browser, share meeting window. I don't see how I can share the PowerPoint.
I think if you click share content, it then lets you pick which screen to use.
Okay, got it. 1 second.
Yeah, that's we've got your PowerPoint in non-presentation mode, but if you
Should be in presentation mode now.
oh no, oh yes, it has. Yeah, it's come up. Okay.
Okay, so this is supposed to be a fun presentation, so don't take it seriously. Okay, this is a what if. What if we could have another model in the Voyager series? Okay, the goal would be to create a new Voyager format calculator. I like the small landscape format. It's very convenient. So the goal would be to create a new Voyager format calculator that followed previously proven interesting function sets. I'll explain. It would be likely acknowledged that the Voyager model would have less volume than the 12, 15, or 16, so there would be a drive to maximize the leverage of an existing model. So as far as the function set, there's a long history of multiple HP calculators that have extended the basic calculator function set by adding statistics, probability distributions, and trig functions. Up in the corner, you can see the 10B2, the 20B, the 30, the 27 was a favorite of mine. As my senior year in college, when I took the engineering training exam, we were allowed one non-programmable calculator. I was a lab proctor for a networks lab. I tracked down a student that had one of these so that I could have both my scientific and my financial functions. And then over on the left is the 21S. So there's a long history of extending the financial calculators by adding scientific functions and statistics functions. So we would create a financial plus scientific calculator with financial probability distributions and trig. The constraint would be no electronics or display changes, no key changes, and we assume, maybe a big assumption, that it's okay to change the keyboard overlay, and additional firmware would fit within the hardware architecture of the Swiss Micro system. So we start with the 12C, the Swiss Micro's 12C, with the 12L hardware as is. We don't change the electronics, we don't change the keys, and we only change the overlay and firmware. So this is what a 12C looks like now. Okay, and see if I can get rid of this. Yeah, there. So this is presenting a candidate 12 DM17L. It's got all of the 12L's functionalities, most of the 27's functions. It doesn't have pi and percent sum. It has a lot of the 20, 30, and 21S probability distributions. Again, a lot of firmware work and a change to the overlay, but no, it doesn't change any of the keys. and it has historically standard labels. So this is consistent with the HP products, except there are two exceptions, and they're both on the same key down here. FSE stands for Fixed Scientific and Engineering. It's a three-way toggle. And DRG is Degrees, Radians, and Grads, which is also a three-way toggle for the trig modes. But you can see the additional functions are in yellow above the numeric keypad and above the add, subtract, multiply, and divide. So that if I could, wave my magic wand and get a calculator, this is one I would like. It's got the trig and it's got the probabilities, distributions, and it's got all the 12C functions. So that's the fun project. Questions?
Very nice.
Please. Why haven't you talked to Swiss Micros about it? That they are open to other things.
I don't have those connections. I'm new to this forum, and I'm just floundering around, listening and trying not to overstay my welcome. So
your welcome is is permanent.
So this is out there now, and I don't want anything for this other than I'll buy this if it's ever available.
I'm curious, Chuck, why did you pick base 10 log and 10 to the X versus natural log?
It's already there. Natural log's already in the calculator. It's already over here.
Oh, you're right. Okay. Yep. You got it. Yep.
So these were missing. So those got added. And then, permutation combinations, and then normal, T, F, and chi-squared are the distributions that are on the other HP calculators. And then the standard trig, sine, cosine, tan with inverse and rectangular polar.
Very cool. I want one too.
If you put the 10x and the log as shifted, you'd have a spare key, since they are opposite.
But you can't shift them. The G's are already defined over the.
Oh, you've got the blue already used, of course. Sorry, I'm just going blind.
Yeah.
Yeah.
Again, this is I strictly said I have to have the same keys as a 12L, because won't understate it. The firmware is the hard part on this, but the hardware, the goal would be you just drop a new overlay on and you're good to go. You can't justify doing another model of Voyager these days without, I would think that without trying to leverage really heavily off of the existing ones.
So I think their biggest challenge would be that I think they are running a ROM emulator, aren't they, for the 12?
They're running a CPU emulator, yeah. And they're only using the HP standard ROM.
Yeah, so they would need some way of taking it so the additional functions either would have to be programmed completely from scratch or extracted from another ROM and somehow jump to, which is going to be a bit of a nightmare, isn't it? You'd almost end up starting again, and
you
just
would have to recreate the whole firmware.
Yeah,
it's a major undertaking.
So
the DM15L, David reverse engineered enough of it to go into the code to modify it to expand the amount of RAM, which is why there are the 3 different memory models, so that the 15L can have more RAM. So he obviously understands the instruction set and has hacked enough at the code of the 15 to be able to do that. But this is just a whole different scope of writing these apps is amazing. Chuck, I have a question. The layout and all that, it looks very logical and intuitive, and we all look at it and say, oh, of course. But how many revisions of this did it take to get all this on there?
I just had fun with it.
More than 1 or 2, I'd guess.
Yeah.
Layout is really hard.
But again, like folks are saying, it's unlikely we'll ever see this puppy because the firmware itself would be a start from scratch, and the work that Swiss Micros did on the 15 was basically changing some address pointers to allow the additional memory, and that's trivial compared to what this would represent. But again, this was only meant as a fun. If I could have this, I'd buy it.
Can you share this presentation?
Yes, I will.
Excellent.
Now, let's see. I'm trying to figure out how to get to the next page. There. Okay. So thanks everyone. Now, one more fun thing that I just added this morning. We were talking about the Unicorn, which was going to release in '85. Another product that released in '85 was the Amiga, the Commodore Amiga. And as it would happen is Retro Games in Luton, UK, is going to be releasing a new version of the Amiga this coming spring, the A500 Mini. And this will do everything that an Amiga or a 500 or the two successive generations of Amiga will do. So I just thought it was, in terms of, we do a lot of work with retro calculators, if you will, and this company in the UK did the Commodore 64 Mini, and now they're going to be releasing an Amiga Mini. Thought that was neat.
That's tiny, isn't it? You couldn't.
Is that just a fake keyboard for the case, and you
Yeah.
put your own on? Because
It's a fake keyboard, real mouse, and it also comes with a gamepad, and there's 3 USB ports on the back, so you can have the mouse in one USB port. They call it a tank mouse, which is the original Amiga mouse. Gamepad and either a memory stick or a keyboard. A standard USB keyboard will plug in. But yeah, that's a non-functional keyboard. It'll have 25 games built in, and it'll run. You can side load as many games as you want via USB stick. It's cute.
What will this cost? Do you have any idea?
Oh yeah, it's $135, $139.
Wow. I attend the retro computer fairs, the what is it? I can't think of the name of it, but there's a conference that cycles around the country 3 or 4 times a year and to EU once a year. And whenever they're in this area, we go to them, and there's an amazing amount of retro machines being rebuilt and brought back and restored, all to play games.
Yep.
No, it's really pretty impressive.
And let's be honest, not especially good games.
Yeah, sure.
Well, we can call them classics, but they are quite antiquated.
Yeah, none of them will play Doom.
No. We have a question which Chuck, I think, is probably ideally suited to answer around the silicon on sapphire process in the original Voyager series, how difficult it was. That's from the YouTube chat. Was it silicon on sapphire?
I don't know the exact process of the original generation. The single chip series 10 that my team did, which was the second generation of Voyager. It's the one I wrote the article that I sent in to you. That was just a straight CMOS process, and it was done in Corvallis. It was not a sauce process.
Right. Okay.
Chuck, when that was done, when you guys did the second generation of hardware, was it a requirement to meet the same battery life that the first generation had?
We wanted to either meet or beat the battery life, so we actually had a better battery life.
Oh, really? Interesting.
Yeah.
So there was a lot of awareness that that was a critical feature.
Yep. The challenge with the second generation Series 10, and again, this is tried to capture some of this in my article, is the original Series 10 were the schematic was a hand-drawn E-size logic schematic that I don't know if you guys remember the green logic templates.
Yeah.
It was hand-drawn with one of those, and E-size sheet was the schematic for the whole system, the CPU and everything else. And so we took that hand-drawn schematic and we took the integrated circuit test program, which actually had the ROM code in it because of the original of the first generation. We took the first generation test program, that and the hand-drawn schematic and the user's manuals, and those were the input to the second generation design. And the original artwork was also for Voyager was originally hand drawn, and it was hand drawn on a 2648 graphics terminal, which is a black and white HP graphics terminal. And so every rectangle was hand drawn, and the continuity check was they plotted out the artwork on a flatbed Versatech plotter, which was in the first floor of building 3. And the plotter itself was size of 2 good sized rooms, flatbed. And so you get this Mylar plot, and you use colored pencils on the Mylar, and the schematic was on blue line, and you did highlighter on the schematic, and that's the way you did the schematic compare. The second generation, we actually did place and route of standard cells because the CMOS process was more dense. And the calculator division, we were in the components operation, the calculator division said it couldn't be done because you just couldn't get the density. So the big challenges for the project, power wasn't one. The standard cells came in a good enough power, but to get the density so that the part would be small enough so that the part would be a cost reduction of the first generation was tough. And when we did this back in the early 80s, the calculator guy said, well, you're wasting your time doing this cost reduction because the 12C is going to die in a year. It's going to be replaced by, we're doing this Pioneer series and whatnot, and these are all going to obsolete the Voyager series. So you're really, this is a waste of time. And turned out not to be. This was only the second generation. HP, elsewhere, I hope in the book, HP will talk about some of the other generations of 12C that are out there.
Yep, Cyril has written about that for us.
And by the way, I said the manual was one of the inputs to the project. Well, it turns out that when we built the first versions of the calculator, it passed all of its test program and everything else, and the ROM was the same and whatnot. HP, and this is the true tradition of rock solid quality, hired a bunch of people to run all of the key sequences of all of the Voyager manuals through the calculators built with the new chips. And it was there that they found that there was a race condition in the new chip where when you pushed on period to put it in European mode with commas, with a comma instead of period, commas went across the entire length of the display. And so the hand entry of the user manual of all of the key sequences in the user manual was what caught that bug before it ever got out in the market.
Very good.
Okay.
Brilliant. Thank you very much, Chuck, and thank you, Sylvan, as well. But 3 interesting talks. I haven't found any other questions on YouTube or on our chat, unless I've missed anybody. Shout up if you've got any more.
Well, can I ask one then?
Yeah, go
on. I know remarkably little about the 2nd generation. Where can we find out more about it? I know that the hardware was upgraded from time to time, but you guys seem to know all about it, and I hardly know anything about it. When exactly was it? Was it 2 years afterwards, or was it done because the 15C and the 16C were being brought in, and at the same time you did new hardware? How did this come about?
So there was a little bit of politics involved. So the calculator division and the components operation were 2 different divisions or business units within HP. The general manager of the calculator group negotiated with the GM of the components group and said, okay, I want you to do a cost reduction, and I want you to have the cost reduction by this date. And so as of this date, I will only want to pay this much for the calculator chips. Okay, so when I became the project manager for the chip, that date had already passed because the components group didn't start the project when they needed to start it. And so the components group was selling the chips, the old chips, at the new price. And so there was a lot of pressure on the team to get these new chips out as soon as in the new less expensive process as soon as possible. And so we pulled together a team from around the world. A person that went on to be the R&D manager for the HP Singapore site was on the team. A person that became the R&D manager for the Penang site was on the team. Some of the original people from the Voyager team were on the team. So the goal of the game was to release this new chipset as quick as possible, so that the components operation wouldn't lose money. The calculator group was getting the chips at the lower price. So, and this was all a part of doing cost reductions on the Voyager series, so that they could keep that product line profitable.
Thank you.
And you'll be able to read more about that in the forthcoming Recall 40.
Exactly.
Thank you.
When those kind of motives, I'll say, for reducing chip costs or component cost came about, was that due to overall sale price pressure on the street, or was it more about trying to motivate larger profit margin?
It's trying to maintain the profit margins. Back in the day, HP's markup was pi.
Right.
So
even into the Voyager stage, yeah.
Yeah.
Interesting.
So the Voyager products, I mean, HP, when you're selling instruments at $10,000 or $20,000, it's a little easier to do that. But for the calculators, the prices were low, so it said you had to reduce the cost, and that's eventually what drove the manufacture of those calculators from Corvallis to Singapore to Penang to wherever. The second generation calculator and the first and second generation Voyagers were made in Corvallis. 3-shift operation, Corvallis had its own wave solder, and it was fun when we did the chip. I went out to the manufacturing line, young engineer, so no excuses. I went out on a graveyard shift to see how the calculator builds were going, and it was funny. The operators said, "Oh wow, we don't see engineers on this shift," but so it was fun talking with the folks that built that.
Chuck, do you remember the time frame when the chips with the improved process were available? Just looking at the introduction dates of the various models, and just to answer Vladik's question about correlation with new models and that sort of thing. Do you remember when that was by any chance?
Not offhand. I've got Mark asked me the same question, and I'm pulling up the chip picture for the single chip series 10 to look at the date on it to verify it.
You'll just have to read the book, Bob.
A salesman. Very good.
You must be getting a cut there, Mark.
If only.
You are. You're getting a cut of 0.
Yeah, the same as everybody else's.
Yes.
Okay. Real.
Great.
I think we're sort of done there then, aren't we? Thank you once again to Chuck and to Sylvan for their presentations. They were great. I did like the thought exercise. I'm tempted now to go and dig out some other calculators and come up with overlays that might be able to turn them into something a bit different. That's a fun exercise. Okay, so I think what we could do there, we'll stop the YouTube stream and we'll carry on if people want to stay on. Yeah.
Can I bring up the annual general meeting?
Yeah. Shall I? I'll stop the stream if that's all right. Yep. Okay.
Stopped.
Thanks, guys. Not yet. Hold on. Here we go.